GMAT all day.
Another useful tool to have in your divisibility skill set is to be able to find the least common multiple of any two numbers. So what is the least common multiple? It is the smallest number that is a multiple of your two numbers. So for smaller numbers, it is easy. If I were to give you 6 and 8, you could probably just see in your head that the least common multiple is 24. 6 times 4 is 24. 8 times 3 is 24. 24 is the smallest number that is a multiple of both 6 and 8. And even if you can't see it in your head, you can just start writing out the multiples of 6 and the multiples of 8. And the first one that they have in common is going to be your least common multiple. That's 24. Now, how do you do this, though, for much larger numbers? So what if I were to ask you, what is the least common multiple of 3,080 and 21,700? So how can we use our divisibility knowledge to find the least common multiple of these two numbers, or for any two numbers? So let's do that. Let's take a second to think about what the least common multiple is saying. It's saying if we were to, for any two numbers, if we were to break those two numbers up into their prime factors, well, any multiple of those two numbers needs to contain all of the factors of both numbers. So the least common multiple is going to contain the bare minimum number of prime factors so that you can make each of those two numbers and nothing else. So let's start by breaking these numbers up into their prime factors. 3080, we broke it up into 308 times 10, 2 times 5 here. This should be divisible by 4 because 8 is divisible by 4. 4 goes into 28 7 times. 77 times 4. So we got 3 2s, a 5, 7, and 11. What about 21,700? That's 217 times 100. This is 25 times 4. It's 2 2s and 2 5s. What about 2017 or 217? Is that prime? I don't think we can use any of our divisibility rules. It's not divisible by 3. You might just have to guess. It's not going to be divisible by 5. What about 7? I think we have a winner. 31 times 7. So 217 can be written as 2 2s, 2 5s, a 7, and 31. So these are called prime boxes. They are just boxes that contain all the prime factors for a number. These are prime boxes for 3080 and 21,700. So how can we use these to get our least common multiple? So what we want is, we want to find the least common multiple of these two numbers. We need to use the bare minimum number of prime factors so that we can make each of our two numbers. And so what we're doing is we're going to go through our prime factors one by one, regardless of whether they appear in only one of our boxes or if they appear in both of the boxes. And we're going to select them the number of times where they appear the most. So sometimes I remember this by least common multiple means you select your prime factors the number of times they appear the most. So least goes with most. So if we start with our 2s, I have 2 2s over here and I have 3 2s over here. So I need to select my 2s 3 times because I need enough to make the 3080. But then I can use 2 of those 2s to also make the 21,700. So I don't need 5 2s because I can use 2 of the 2s over here to make this guy over here. What about my 5s? I have 1 5 over here, 2 5s over here, so I need both of those 5s. And then I can use one of them to make 3080. 7 appears once in both of our guys. And 11 only appears over here, so I need that. And I need the 31 so I can make the 21,700. This is our guy. This is the least common multiple of 3,080, 21,700. Now if we want to actually get the final number, I would say the easiest way is try to pull out either a 10, 100, or 1,000, something that ends in a 0. So we got 100 here and a 2 here, so that's a 200. We have 200 times 7 times 11 times 31. So 7 times 11 is 77. So 200 times 77, that's going to be 2 times 77 with 2 zeros tacked on. So 77 times 2 is 154. 200 times 77 should be 15,400 times 31. That should just be 154 times 31 with 2 zeros tacked on. What's 154 times 31? 4, 5, 1, 12, 16. This is our final number, 477,400. So let's take a look now at how they might actually test this on the GMAT. They probably would not give you numbers this crazy. So it says if m is a multiple of 55, 176, and 200, which of the following statements must be true? So this is another thing that they can do. They can ask you least common multiple questions without really using the words least common multiple, because what they're doing here is, think about it, they're saying what must be true. And so if we think about just all the multiples of 55, 176, and 200, well, there are infinite such multiples. But we want to find what must be true about all of them. So there are infinite multiples. There are lots of things that could be true about any number that is a multiple of these three numbers. But the only thing that will be true for all of them is that they will all contain the least common multiple. All of your multiples are just going to be multiples of that least common multiple. So the only thing that must be true is they will contain the least common multiple. And so this question is really asking, what is the least common multiple of 55, 176, and 200? And so when we have three numbers, it's no different than when we had two numbers. You just got to take into account an extra number. So break these guys up into their prime factors. 55 is just 5 times 11. To the 200 next. 200 is 100 times 2. We got 3 2s, 2 5s. That's it. What about a 176? 88 times 2. This is 44 times 2. 11 times 4. So here we got 4 2s and an 11. So if we want to find the least common multiple of m, same thing as before. So let's go through our numbers one by one, select the times they appear the most. So starting with our 2, we have 4 2s here, 3 2s here, none here. So we need all 4 of those 2s. So we can make the 176. And then we will use 3 of those 2s to also make our 200. 5 appears twice here, only once here. We got to go with it twice. And then I think the only thing left is our 11, which appears once in each of these guys. But we only need it one time. So this is our number. Let's see if we can get away without actually having to multiply it out. If we can just leave it as this expression, save ourselves a lot of time. So what must be true about this number here? Does it have to be divisible by 8? So does it contain an 8? And we have 3 2s here, which gives us an 8. So it definitely is going to contain an 8. Now remember, so if we're talking about just, this is the least common multiple then, if we're talking about any multiple of these three numbers, it's going to be the least common multiple just times some constant, times some integer. And so even though if this integer contains an 8, our multiple will be divisible by 8, we only care about what has to be true for every single one of these multiples. So we only care about things that we know from the least common multiple. And because the least common multiple contains an 8, all of our multiples will contain an 8. So statement 1 must be true. Therefore, anything that does not contain a 1, we can eliminate. Not super hopeful. They all contain a 1 except for B. So what about statement 2? Does M have to be divisible by 800? So from here we have a 100 using 2 5s and 2 2s. But then it looks like, so we need 3 more 2s, but we only have 2 of them. So M will be divisible by 400, but not necessarily 800. It could be divisible by 800. If, for example, I get an extra 2 from over here, then it would be divisible by 800, but it is not necessarily true. So we don't know this. Anything that contains a 2 can go. We're left with just A and D. And even though it looks like we avoided it up until this point, I think for the third statement, we're going to actually have to find this number. So does M have to be greater than 4,800? So if the least common multiple is greater than 4,800, then all of the multiples will be greater than 4,800. We got to find what this is. And I actually don't think it's going to be that bad, because here we got 100 times 4. This is just 400 times 11, which is 4,400. So even though it is true, most of our multiples of these three numbers are going to be greater than 4,800. It is not necessarily true, because it also have the least common multiple of just 4,400, which is less. Only the first option is true, A.